In our previous video, we talked about generics. We saw that how generics helps us to decouple the data type from the logic. Now, taking that concept, that is decoupling the data type from the logic, it was applied to .NET collections, and a new type of collections was emerged called as generic collections. So in this video, we'll talk about what are generic collections. Now, the next kind of question you will ask me is that, so what kind of logic are we trying to separate from the data type in .NET collections or in .NET generic collections? See, the logic is nothing but the collection itself. When we look at any collection, right, we expect that it should have add logic, remove logic, clear logic, search logic. So if somehow we can separate this collection logic and make it generic, by separating it from the data type, that would be great. And that's where, .NET framework has one more type of collections called as generic collections. And this generic collection actually helps us to separate the logic collection, the collection of the logic, from the data type. So now the next question, how do we actually use generic collection? Now, what the .NET development team has done is, they have taken the .NET collection and they have applied generic concept on it and created generic collection. So for example, let's say that if you talk about array list, right, they applied the generic concept on it and created a generic collection called as list. For example, hash tables, they applied the generic concept on it and created something called as dictionary. For example, stacks and queues, they applied the generic concept on it and created stack generic collections and queue generic collections. So in other words, every .NET collection type has a generic collection. So in other words, if you want to have an index based generic collection, you will use a list. If you want to have a key based generic collection, you will use a dictionary. If you want to have a prioritized based generic collection, you will use a stack and queues generics. Now, all of these collections, right, are available in a new namespace called as system.collection.generics. So if you want to use the dictionary, the list, the stack generic collections and queue generic collection, you have to ensure that you import the namespace system.collections.generic. So let's start with some samples for generic collections. So what we'll do is, first let's demonstrate a simple sample of index based generic collections. Okay, now the first thing is you have to remember that you have to import the system.collection.generics namespace, or else you won't be able to find the generic collections. Now if you remember, right, index based collections are nothing but array list and arrays, right? So just to revise. Okay, so for generics, what we have is we have something called as a list. So type list and you can see that there is a generic collection for it. So if I want to create a list of type integer, I can say list of obj is equal to new list of int. And now you can see that how easily I have attached the data type with my logic, that is list logic, the collection logic called as list. And if I do a obj.add here, you can see that it's also strongly typed. So I can just add integers here and no other data type here, right? So in other words, we were able to use the list logic and we were able to attach the data type of int with it. In the same way, if I wish, I can also go and attach this list with a string if I want to, or this list with a boolean if I want to. So in other words, I can now go and attach any kind of data type with my list logic. So boolean. Now if you see this here, I can just add boolean data type here. So as we have said previously, that this is an index based collection, that is a list is nothing but it's a generic form of the array list. It's an index based collection. So in other words, if I want to get data from the list, right, I need to use the internal index number, and you can see that when I do obj, I can get the data by using the internal index number. Now the next kind of generic collection which you would be interested is the key based generic collection, where you would like to fetch with a key, as we did for hash tables. Now for the key based generic collections, we have something called as dictionary. Now for dictionary, again simple, you have to say dictionary. Now remember that, as we said, that dictionary is a form of hash table. So you can see that the dictionary says that, okay, what kind of data type should go for the key and what kind of data type should go for the value, because remember that dictionary is a key based collection, right? So let's say that I say, okay, the the type of data type for the key is int as well as the value is int. Okay, and I'll say obj dictionary is equal to new of dictionary of int and int. Now if we try to use the obj dictionary and if you call the add method, you can see that both the key as well as the value is a strong typed integer. Why? Because we have defined, when we created the dictionary, we defined that the key and the value should be int. So that's why you see that we can just add integer values for both key as the value, right? So in other words, dictionary is nothing but it's a generic form of hash tables. The next type of collection which we are interested is the stack and queues. Now, for stack and queues, the vocabulary is the same. For example, here we saw that for array list, the generic collection was renamed as list. For hash table, the generic collection was renamed as dictionary. But the good news is that for stack, the vocabulary is same. So I can go ahead and I can say stack of, let's say, int. Okay, o stack is equal to new stack of int. So now if I can go and add data to the stack by using the push method, you can see, and I can take data out of the stack by using the pop method. So you can see pop. Now if you closely see the pop method, right, you can see that it's returning an integer type here. So even the return type has now been modified as per the data type which you have attached with the stack logic. In the same way, we can do the same for queues. So I can say queue of int, queue obj is equal to new queue of int. And if you remember, right, for queue we need to use the enqueue and dequeue function. So you can see that's the enqueue. So I can say 1, and if you see the dequeue function, queue of obj dot dequeue, it's returning end data type again. Now till now we have attached only what you call .NET data types like integers, strings and booleans with the generic collection. But if you wish, right, you can create your own custom data type. Like for example, you can go ahead and create a simple customer class, and you can attach that simple custom data type also to the generic collection. So for example, here I have created a very simple class called as CLS customer with a customer code property. Now I can go ahead and create a list here, you can see, and I can attach this customer data type with the list. Okay, and I can create a strongly typed customer list. And if you see the add method, you can see that I can just add customer data type to this list. I hope that you have enjoyed this video. In this video we saw different forms of generic collections like list, dictionary, stack and queues. Now in the next video we'll talk about interfaces of collections. I'm sure that every developer must have heard these words like IEnumerable, ICollection, IList. But rarely many developers know about what to do with these interfaces. So in the next video we're going to talk about what are these interface collections and how they help us in real-time project scenarios. Thank you very much.